Hello everyone, today we'll be starting projectile motion, and in this video we'll be going to complete the motion in 2D, motion in a plane chapter. Okay, and the remaining part which is there in the kinematics, I'll try to complete it in another video. So we had different types of problems in chapter motion in a plane. So we had in the motion and plane we had different kind of problems. Okay, in different kind of problems we had relative motion, projectile motion. In relative motion we covered in the video, it's given there. We had four types. This is the first case where we have initial velocity to be zero and the acceleration, acceleration g. Okay, this is the first case where initial velocity is zero and the acceleration. The second case is initial velocity parallel to the acceleration. You see here it's parallel, initial velocity and the gravitation both are parallel. And the third case is where the initial velocity is opposite to the direction of the acceleration. Okay, it's opposite, anti-parallel vectors. Okay, so these are the three cases. In all other cases where when initial velocity is at same angle, not equal to 0 or 180 degree with constant acceleration, motion is a parabolic as shown below. This motion under acceleration due to gravity is called projectile motion. Now what is projectile motion? Okay, suppose we throw a ball. Okay, the ball goes and it hits the ground here. Okay, so in the projectile motion we'll be seeing that at low heights. Okay, so at low heights g is constant. Okay, when the height is low, these are low heights. Okay, so the g is constant. So the motion which is under uniform acceleration, now this is the motion where we have uniform, everywhere we have a uniform g. Okay, so motion under uniform acceleration gives us a parabolic. Okay, parabolic. The acceleration motion is in parabolic. Okay, so the motion which is under the uniform acceleration, we get a parabolic. And in the projectile motion at low heights the value of g is constant. Okay, so there is a uniform acceleration. Uniform acceleration in means that there is a constant change. So there is a constant change in velocity. It says that constant velocity, that at every point the g, okay, I say g a, it's the same. So v2 minus v1 will be t2 minus t1. This will be constant everywhere in the parabolic. Okay, in this parabolic motion. Okay, so I repeat once again, the motion which is it at constant or uniform acceleration, it forms a parabolic. Okay, and this is called projectile motion. Okay, and in projectile motion we have a constant acceleration. At low heights g is constant. G is constant in sense a is equal to g, which is acceleration. Okay, so acceleration is constant. Acceleration constant in sense the constant change in velocity. We know what is acceleration. Acceleration is a change in velocity by time. Okay, so at every point in this motion we will have v2 minus v1, t2 minus t1 is constant at every point. Okay, now we come to the different types of projectile motion. Here are the different types of projectile motion. The first one is horizontal ground. Okay, these are the tower based problems where we have, this is the tower. Okay, here we fire something and then it happens a projectile motion. Here is the up the plane projectile and here is the down the plane projectile. Okay, the plane of the projectile motion is a vertical plane. Now we'll be discussing every of the types. Now it comes the two methods of solving a projectile motion. The first method is projectile motion is a two-dimensional motion with constant acceleration. Please please be careful with this line. They can ask a simple MCQ question is that parabolic motion with constant acceleration. You'll be given some options, and there you can easily tick out yes, it's a projectile motion. So projectile motion is a two-dimensional motion with constant acceleration. Therefore, we can use the equations v equal to u plus at and s equals to ut plus half at square. Okay, where a is equal to g. Okay, the second method is, in this method select two mutually perpendicular directions x and y and find the two components of initial velocity and acceleration along these two directions. Find ux, uy, ax and ay. Okay, now apply the appropriate equations on the following six equations. Vx equal to ux plus axt, xs, x the x-axis, okay, along the x-axis, ut plus half at square, v square equal to u square plus 2ax. Now this is in x axis and this is in y axis. So these are the two methods. Okay, one is we can simply take out by these two formulas, and then we can take the two components and we can take out the projectile motion, the velocity, the initial velocity, the displacement, the time taken, and the more things. Okay, now we come to the problem. Problem is there, a particle is projected with a velocity of 50 meter per second at 37 degree with horizontal. Find the velocity, displacement and coordinates of the particle with respect to the starting point after 2 seconds. Given g is equal to 10 meter per second per meter 10 meter per second square, and sine 37 value is given and cos 37 value is given. Now note that in all problems value of a equal to g will be only u initial velocity will be different at every point. The acceleration will be g, but initial velocity will not be same. Okay, it will be different. Now we'll be taking out the components of u. We made a diagram here. Look, so what was the question saying? That the projectile motion, the velocity is 50 meter per second at 37 degrees. So we calculated here. It's shown. Now this is horizontal ground based. Okay, you see here, or it's an horizontal ground base. Okay, this is the x-axis, this is the y-axis. Okay, the same is here, right? So g is everywhere, it's constant, so the motion will be something like this. Okay, now first we'll be taking out the components. Okay, the components of the initial velocity, u sine 37, u cos 37. Okay, and we took out that u is the summation of these two. Okay, so 50 cos 37, 50 sine 38. In the look here, it's I cap and j cap. I cap indicates x axis, j cap indicates y axis. Now if you did not see the lecture vectors, please go and see it. I'll give the link in the description box. Okay, you can see and you can go there. So initial velocity is 40 I plus 30 j cap, and the acceleration is in minus 10 j cap. Why it's j cap? We know that acceleration is in this direction. Okay, so when you go to solve a question, first make these two axes. Now this is g. Okay, gy in y direction, it is minus 10, right? It is minus 10. When we go down, then we get a negative value, and when we go up we get a positive value, right? So g in the y axis, it's minus 10 j cap, but in jx we have 0. We don't see an acceleration in this direction, do we? No, we don't. So g in x direction, x in x axis is 0. Okay, so we wrote here only j cap. We can also write 0 I cap. Okay, minus 10 j cap, but this is of no use, so we only write 10 j cap. Okay, and we simply put in the formula v equal to ut plus u plus at. You're seeing here, and we get the final velocity, and by getting the final velocity we even get the displacement. Now in the displacement formula, where we have s equals to ut plus half at square, we take out, and this is the displacement covered. Okay, what did the question say us to take out? We see here that they said that find velocity and find displacement. So we took out the velocity here. It's simple of using these two formulas. We saw here that the method 1, you're seeing here the method 1, v equal to ut u plus at and s equals to ut plus half at square, where a equal to g. So we simply solve this question, an easy question. Now we come, okay, the coordinates of particle are x equals to 80 meter and y equals to 40 meter. Okay, here's another question. A particle is projected with velocity u at an angle theta with horizontal. Find the time when velocity vector is perpendicular to initial velocity vector. We took out where here they said that the when velocity vector is perpendicular to initial velocity. So we take out the perpendicular. Now while we know this that v is perpendicular to u, so the dot product will be 0. Now we got an equation here, u plus at dot u equal to 0. Substituting the proper values in equation, we get this. So we took out the components of the initial velocity, okay, and we put it here in the direction. This is j cap, this is I cap, okay, this is j cap, this is I cap, and here after solving it we get t equals to u by g sine theta. Now 1 by sine is equal to cosec, so we can also write u cosec theta by g. There is an alternate method too, where a equal to g and the angle between u and a is alpha, which is 90 plus theta. Okay, now in the equation v dot v into u u into dot plus u dot at, u square plus ug cos alpha, okay, this component, okay, this is u cos and this is u sine, okay, u square plus ug cos 90 plus theta t equal to 0. So solving we get t equal to u by g sine theta, u equal to cosec theta by g. There were some alternate methods solving in these two questions, but the main thing was that, so mostly we saw that we could solve the problem. So we could solve with these two equations, v equal to u plus at and s equals to ut plus half at square, where a equal to g. So this was method 1. Now I show some example how to solve the question with method 2. Okay. So here we have there are two examples. So in this basically we need to do, first we need to see that taking out the two components. Now look at here. When we need coordinates, then we need to see that which, like this is u cos theta, okay, and this is u sine theta, okay. So we know that ux is u cos theta and uy is u sine theta. We know this, right? And now we will see that there is a constant, a uniform acceleration. So as I said earlier too, the gx will be 0 because we don't see acceleration in x axis, do we? We don't, right? So this will be 0 and the gy will be minus 10 j cap or whatever the value is, okay. Now we took out here that the ux, uy, u cos theta, u sine theta, and like this we calculated it out. Now we come to the question. A projectile is fired horizontally with velocity 98 meter per second from the top of a hill 490 meter high. The time taken by the projectile to reach the ground, we need to take out this, the distance of the point where the particle hits the ground from foot of the hill, and the velocity with which projectile hits the ground. G will be taking 9.8 meter per second square. Now here this will be the diagram. First we need to make this two axes which we followed. So the down one is y and this is the x. Okay, this will help you really a lot when you solve the questions. So first here it will be more convenient to choose x and y direction as shown in the figure. Okay, here ux is 98 meter per second, ux, okay, it's in x direction, right? So look here, this was somewhat the diagram, right? So they gave it is 98 meter per second. Now we know that this is x direction, this is y direction. So ux will be 98 meter per second, right? Ax is 0. Okay, look here. Uy will be 0 because we don't have a velocity in this direction, do we? We don't. And the same with acceleration, gy will be 9.8, but gx will be 0. We don't have an acceleration in this direction, do we? We don't. So here we took out these things first, the easy things. Now, what was this method actually? We needed to calculate the both things along x and along y axis. Okay, so we'll do this. Now we'll be calculating the displacement. Okay, so the displacement sy is 490 meter, right? It's 490 meter. Now, so applying this equation s equal to ut plus half at square, we get the time as t equal to 10 seconds. Okay, if you can't understand it, then I tell you, look, from the top of a hill, 490 meter high. Okay, this height. Okay, so the displacement was 490 and we equated and we got a we got 10 seconds. Okay, now we need to calculate what we need to calculate. We calculated here the time. Look, here it's given the time taken by the projectile to reach the ground. Now we take out the displacement of the point where the particle hits the ground from foot of the hill. Okay, so now we'll take out in the x direction. Look here, this was in y. Okay, now we'll take out the sx. Okay, so here it is ut plus half at square. Moreover, in projectile motion, we'll always be helped with the formulas I gave you in the motion in straight line video. I'll give the description and I'll give the link in the description. V equal to u plus at, s equals to ut plus half at square, and v square equal to u square plus 2as. These three equations will help us a lot in solving the equations, in solving the problems. Okay, so we take out the displacement, it is 980 meter. Now what they said us to calculate is the velocity with which the projectile hits the ground. G is 9.8 meter. So here we can easily take out the formula. Here we know V equal to U plus AT, right? Okay, so we look, now this is the V. So V is the resultant, so we will take out first Vx and Vy, and then we'll take out the resultant. We know the formula, right? A square plus b square plus 2ab cos theta. If you don't know vector, please go and see the vector video, and then the vector video will help you a lot to understand the problems in motion in a plane. The problem we have here, the relative motion, the projectile motion. Okay, so the Vx is 98 meter per second and the Vy we calculated is 98 meter per second. So both the components, both the common Vx is 98 meter per second and this is 98 meter per second. So we'll take out the resultant, and here we take out the resultant and it comes 98 root 2. So this is the velocity. Okay, this is the velocity, and the angle between them is 45 degree. Okay, thus the projectile hits the ground with velocity 98 root 2 meter per second at an angle beta of 45 degree with horizontal. So the question got solved. Now everything which is written here, I'll provide you the PDF in the description box. Okay, so we have the next question. A body is thrown horizontally from the top of a tower and strikes the ground after 3 seconds at an angle 45 degree. With the horizontal, find the height of the tower and the speed with which the body was projected. Take g equal to 9.8 meter per second square. Here again we'll be taking out the everything in x and in y. Look, here we discussed here that we'll take out both in x axis and in y axis. Okay, so we did this. So we do this here, we took out, and then the height of the tower we get 44.1 meter. Look, here we took out the SY, okay, 41.41 meter, and which is the height of the tower. It is the height of the tower, okay, like this. It's the tower. So this, the projectile motion, this is the projectile motion, okay, the projectile motion PM, and this is the height SY. I told you. Look, first we will be taking out, this is my x-axis, this is my y-axis, and the height of the tower we take out with the formula, with the help of the formula ut plus half at square, and we got the displacement at 44.1 meter. Now, as the resultant of the resultant velocity, v makes an angle of 45 with the horizontal. So tan 45 is vx by vy by vx, and 1 is equal to 1. So 29.4. We took out the velocity in y direction. Okay, in the y-axis we got 29.4. So from this help we got the vx. The vx is 29.4 meter per second too. Now we'll take out the resultant velocity. Okay, it's the same case where we had same. We know that it is forming a beta. The beta is 45 meter, 45 degree. Okay, so this will be of course 45. Then we can say that it is 90 degree. Yes, we can say it. So we'll be taking out the resultant. This is 29.4. This is also 29.4. Both in the both along the axes. And then we got the resultant of the v. Okay, but and now here we have vx equal to ux plus axt. What we needed to calculate. Look here. Find the height and the speed with which the body was projected. Okay, we need to calculate the velocity, this velocity here. In the tower, we need to calculate this velocity. Okay, so here we calculate it. Vx, we took out the Vx. From here we took out the Vx. So now we can equate in the formula along the x-axis here. Look. Along the x-axis, vx equal to ux plus axt. Okay, so we put in the formula and we get 29.4 meter per second is the initial velocity. Okay, it is the speed with which the body was projected. Therefore, the speed with which the body was projected horizontally is 29.4 meter, and the height of the tower is 44.1 meter. Here are some questions in the description. You give me the answer in the comment box if you watch the video till here, but I just see you that these two questions answer. The rest you calculate and you take it out, and if it's a problem, then I'll take these three questions in my next video. Okay, the problem section. The projectile motion is a three-dimensional motion. I said you here. Look, projectile motion is a two-dimensional motion with constant acceleration. What is this two-dimensional motion? So we know it is false. Right? Projectile motion at low speed is uniformly accelerated. Projectile motion isn't uniformly accelerated, so this is true. Uniform acceleration. And these three questions I'll be discussing. Now we come here to the main points of the projectile motion. Okay. Look, we need to calculate now the h max, the maximum height where v1 is equal to 0. Here the v2, okay, here u2 starts to have a velocity, and here u1 is 0. Okay, when it starts it has a 0 velocity, and then it comes. So at the point where the body just gets stopped, so the maximum height, the range, the displacement it covered along the x-axis, and the time taken, we will be seeing these three things. Okay, now in the figure it shows a particle projected from the point O with an initial velocity u at an angle alpha with the horizontal. It goes through the highest point A and falls at B on the horizontal surface through 0. This is the diagram. Okay, follow it. The point O is called the point of projection, and the angle is angle of projection. This angle of projection, and this is the range. This is the time taken, the constant acceleration. This is h maximum. Okay, the vertical height, everything will be given in the PDF. You can go and read there from there. So the time of flight, the total time taken to cover the projectile motion is t equal to 2u sine alpha by g. Okay, I'll put the derivation in the next video if it's really required. So the time of flight is t equal to 2u sine alpha by g. Maximum height is the where the final velocity is 0. As I said here, right, where the v1 gets 0, the maximum height. So the formula of maximum height is u square sine square alpha by 2g, and the range is u cos alpha t. Now it is u square sine 2 alpha by g. Now range is u cos alpha t. What is t? T is u sine alpha by g. Now this cos is the u. So in the x axis we have u cos theta. Okay, u cos alpha. If I took so u cos alpha by t, or if you can write r equal to u square sine 2 alpha by g. Now in this we need to first see the time sine 2a's formula, and then we'll be able to take out the range. So here we talk about the time of flight, the maximum height, the range, the displacement along the x-axis covered. Now if the range is 45 meter, then it's the maximum range. Else if it's somewhere near 45 degree, then the range will be similar. I meant to say that if the alpha is 45, range is maximum. Okay, and if we have two projectiles, okay, this is 30 degree, this is 60 degree, so they both will have a same range. Okay, they both will have a same range. Okay, now we take some question. Find the angle of projection, okay, for which the horizontal range and the maximum range are equal. Here we just put the formula and we get the answer. Okay, now we come to the point down the plane projectile. In down the plane projectile, we will first is the most important thing is that we need to first take out the components of the u g. Okay, and then we get there are the formulas of the formula used in down the plane is h max equals to u sine alpha whole square by 2g cos theta. The r is u cos alpha t plus half g sine theta t square, and the time taken is 2u sine alpha by g cos theta. The complete PDF it will be provided in the description. Okay, you can go and you can learn these formulas, which will really help you when you'll have a question in down plane or in up the plane projectile motion. Here we have the h max. Everything is same in down the plane and the projectile motion. Only and only there is a change here in r equal to, here it is minus when you go up in the plane. Why it is minus and why it is plus, here I'll tell you. In the down the plane we have u cos alpha t plus half g sine theta t square, and here we have u cos alpha t minus half g sine theta t square. Why we have plus and minus? Let me tell you one thing. When you go down the plane, then you run along the g, so we have positive, and here we oppose the g, so we have negative. So up, when you go up, g is negative, you oppose the g. When you go down, you are with the g's direction, so it is positive. Understood? Everything is same. The h max, the time, all the formulas are same. Only in the r, here it is plus, here it is minus. Okay, now comes projectile in a moving frame. Projectile in a moving frame, here we have a slab where the boy is standing and he is throwing a ball. So the ball is thrown with a u velocity. So we took out the components, and the slab is running with a velocity vr. Now here we will be considering the velocity. The velocity gets add up when we will be calculating in the velocity in along the x direction. Okay, so the final velocity in the x axis is v equal to vr plus u cos theta. Now the h max formula is u square sine square theta by g, r equal to the velocity, this velocity, okay, into time. The same thing, vr plus u cos theta by 2 u sine theta by g, and the time calculate the time reached for completing this projectile motion is 2u sine theta by g. Now comes the inclined plane. Okay, in inclined plane we have there is a tower, and here we throw the ball, we fire the projectile. So this tower based problems, okay, the different types. So we discuss the horizontal, we will be discussing now the tower base, we discuss the up plane, and we discuss the down plane. So the types of projectile is completed. Okay, here in the inclined plane, the range, the formula of range with this will be calculating by u. Okay, this u into 2h, the height 2h by g, and the time is 2h by g, and the alpha, this degree alpha will be calculating by tan inverse of gt by u. Okay, so this is the main diagram. Okay, this is the main diagram here. Okay, so the range u equal to g, this is u gt, so the alpha you will be calculating is gt by u. So there are some formulas here, we even saw this here. So when you get the pdf, please be very sincere with the formulas and understand where which formula is getting used. Inclined plane, the formula is u dot root over 2h by g, t is equal to 2h by g, and alpha is the theta, the angle formed, the angle of the projectile is tan inverse of gt by u. Okay, so here we complete the chapter projectile motion, and the pdf will be given, and the link of this motion in a 2D, vectors, relative motion, and motion in straight line, and the video of kinematics will be given in the description. Go and see them all. And here we complete, so here we complete the kinematics. Okay, thanks for watching, and please stay tuned for the next upcoming chapters. Thank you for watching.